Hello Math 1324 students, this is Business Algebra Lesson 0. Here we are going to cover all kind of preliminaries. All the topics here in Lesson 0 had been covered previously in either 1303 or 1305. So if you feel comfortable, just skip Lesson 0 and go directly to Lesson 1. Otherwise, here we go. I'm going to cover all these as quickly as possible because all these should be already familiar to you. Set notation, roster notation or list notation like this. I think everybody can easily see that this is the positive multiples of 3. And the same set can be written in set builder notation like this. X and then the condition of X. This kind of notation, which came from element E, with a bit of a rounding, represents an element. So 27 is a multiple of 3, so that belongs to this set. 34 is not an element of S, so it doesn't belong to S. See the difference here? You have this crossing, so that it's not an element. Now, if you remove the middle bar, then we get the subset notation. 3 and 30 are both elements of this S, so put those together, you get a subset. Of course, there are many other subsets. This is an example of a set that is not a subset of S. 33 is okay, but 2 is not. Okay, that was quick, and let's go to the next. Sets of numbers. We're going to be using these kind of notations a lot. N, W, Z, Q, R, C. N, natural numbers, 1, 2, 3, 4, and so on. Or positive integers, they mean the same thing. W, the set of whole numbers, 0, 1, 2, 3, 4, 5, 6, and so on. And then the integers, negative as well. Q, the set of rational numbers, integer over integer. And the set of real numbers, all those decimals included, including non-terminating and no patterns, non-repeating. And finally, the complex numbers. I don't think we are going to be covering complex numbers in 1324. We do those in STEM algebra 1314, but here probably not. Next, interval notation. Here, we stick ourselves only to real numbers between A and B, whether A or B are included or not. If you have bracket, that means included. We have semi-inequality there. If you have parentheses, that means not included. Strict inequality there. One surefire way to remember all this is to write this strict inequality very quickly. For example, A is less than X, kind of like that. And then that's less than B. Well, okay, this one here on the right-hand side looks a bit more like traditional strictly less, strictly greater. But this one, my bad handwriting with this, using this mouse pad, as a matter of fact, did a good job. This looks very much like a parenthesis, doesn't it? So that you can easily associate parentheses corresponding to strict inequality, and by default, the bracket is semi-inequality. That's a good way to remember all these things. Let's get out of this drawing mode. All right, next, algebra of sets. Union, A or B, so either way it's okay. So A is okay, B is okay. Either way it's okay. So or makes it larger. Union makes it larger. Oh, do I have an example here? Example of a union? Okay, all right. Blue is okay, red is okay too. So either X is strictly less than 2 or X is greater than or equal to 5. Yeah, there goes an example. Next, intersection notation. A and B, and makes it smaller. So it has to be inside A and also inside B, so only the middle part. Here's an example. So intersection between this blue interval and red interval is only the middle part. So between 2 and 5, strictly greater than 2 and less than or equal to 5. So union and intersection. Next, complement. Not A, all except A, like this, A, but all except A. And the outer rectangle is the universal set, the domain we are going to consider. If nothing is specified in this course, we are going to consider all the real numbers. And for the notation, we use the C notation or the tilde A notation or just bar notation, straight. There are many other notations. Next, A but not B. So A minus B, kind of like this crescent region, inside A but not inside B. And then B not A. So inside B but not inside A. Those kind of things are set algebra or Boolean algebra, and that completes section 1. Now, shall we go to section 2? Okay, all right, section 2, that's short enough, so I think I can squeeze that in. The basic properties of real numbers. Here are some algebraic properties: associative law, additive identity, additive inverse, commutative law, all those for addition, and then associativity, multiplicative identity, multiplicative inverse, and commutative law, all for multiplication, and then the distributive law. Everything here should be familiar to you already. Otherwise you're going to be in serious trouble. You wouldn't have passed 1301 like this. Next, order property. For any real numbers, A and B, one and only one of these three must hold. Either A is strictly less than B, or A is strictly greater than B, or they're the same. Not both, no neither. One and only one of those three must hold. That's called trichotomy. Trivial, isn't it? Next, transitivity. Names are not that important. The property itself is important. So A is less than B and B is less than C, then A is less than C. Yeah, of course. Everybody knows that. Now, inequality preserves addition. If you add the same thing to both left-hand side and right-hand side, still right-hand side is bigger. Finally, preserving the multiplication of positive real number. Multiply the same positive number to left-hand side and right-hand side, then we have the same inequality, same direction. Now, what if you multiply the negative real number? In that case, we have to flip over the direction of inequality, and I don't think it's wise to go through the proof of this at this level, so just remember it as a property. Okay, finally the completeness property. The set of real numbers completely fills up the number line, so we can do geometry or we can do intervals and things like those. Graphs, all those are associated to these. Here's an example: closed interval A to B. Here's an open interval A to B, excluding the endpoints. And then, of course, we can consider half open, half closed. We saw those before in section 1. So much for the basic properties of real numbers. Now, as for section 3, I guess we'll cover it in the next video. Let's stop here. See you soon.